This video demonstrates the working of a baseplate design software with the help of an example. From support reaction input to completion of 7 sheets of detailed calculations, everything is explained in an explicit manner. This software, developed by our R&D team, designs stiffened baseplates to limit state method of IS 800. It can handle up to 50 support nodes and 500 load combinations. As a result, we do not have to club maximum support reactions from various load combinations into a single one to obtain the governing load case. Instead, we let our software select the governing load criteria, not just for anchor bolt design, but for design of baseplate and shear key as well.
We start our demonstration with our first input sheet that requires support reactions to be entered in this format. Here is an extract of support reactions for those joints for which we intend to design our baseplate. We copy this from here and paste it in our input sheet. And then we go to the next page. Our software is capable of designing baseplates in all of these configurations. Choice of an appropriate type depends on the type of support reactions. In our case, we will choose BP8 as our supports are all fixed type. Here is the input sheet for the baseplate we just selected. Fields in yellow indicate user input, while those in green indicate calculated values. We start with minimum bolt diameter as 20, flange width as 350, and overall depth as 750. We use this facility to fill in remaining fields automatically. These predefined default values are generally based on the design basis for ongoing project in order to save time. Moreover, if an input value is incorrect, an appropriate message prompt appears after this. The software does not allow the user to proceed further unless all of these values conform to the preset criteria based on design codes or the design basis. This takes us to input for material grades. Material properties for various elements of a stiffened baseplate are entered here against respective description in the units indicated. Again, we use default input for all the baseplate components. These can be changed easily to any other value as required by design. Here's an option to allow or suppress the allowable stress increase due to wind and seismic load cases. Shear key is designed as per the options here. It comes in these two profiles. Here we select the smallest UC section as the minimum key size, and this initiates the design. Oops, it says maximum base pressure for this node and load combination exceeds the allowable value. It further recommends an increase in baseplate size. Fine, we increase the width to, say, 900 mm, and length to, say, 1100 mm. And this completes the baseplate design. Design with BP8 type requires 48 dia bolts. If the project calls for lesser diameter for some reason, this is what we can do. Go back to Support Reactions. Then go to Baseplate Selection. This time we select BP9 with 4 bolts on either side. And now we have a revised design with 36 dia bolts. Let us quickly go through the calculations.
Before we take you through design calculations, let me apprise you of a few things. We have designed both fixed and pinned base plates using this software, and we found the design outcome relatively economical when compared with manual design. And this being an in-house product, it would be easy for us to accommodate your specific project requirements, if any. Lastly, I must admit that all features of our software could not be covered in this video. Do let us know if you have any queries or wish to know more about our bespoke design templates.
The governing load combinations factored in for stress increase and shear key presence are as highlighted here. In our case, these are all different for anchor bolt design, baseplate design, and shear key design. This is followed by detailed calculations for anchor bolts, baseplate, stiffeners, shear key, and connecting welds. These calculations, produced at the click of a mouse, have a striking resemblance to neatly organized manual calculations for the perfect size of the component being designed thus. The intricate calculations are simplified for easy checking and contain input echo, limiting values from design code, formula used, references to design code, and action versus strength comparison for the various limit states. Interestingly, these calculations can be produced on any other design template with equal ease. Moreover, the incredible flexibility the software offers enables us to absorb the changing needs of our clients without affecting design cost, schedule, or quality. Epicenter. With us, your structure is in safe hands.